Namaste to all of our viewers. This is Sumit Chavale. Welcome to my channel JTC Educational Revolution. In this video, that is Electromagnetism Part 2, we are going to learn about two activities as per Telangana textbook. Right? Okay? So, here our first activity is to see the magnetic field. That is activity number 2 in Telangana 10th class textbook. Our next activity in this video will be to see the lines of magnetic field. If I say together, both are actually related to each other, these topics. Okay everyone? So, let us start with this class. So hope the things are very clear to you on the screen. See, our activity 2. Magnetic field. So we'll try to come to know one by one many points here now in this today's video. Now, what is mean by field? Whenever I discuss about magnetic field, now I must know what is mean by field. Right. After that we'll come to know magnetic field, electric field, many more. Right. Okay. So what is mean by field here? Field is nothing but suppose force is exerted on an object without being in physical contact. Right. So for this type of scenarios, we use the word field. Okay? For this type of scenarios, we use the word field. Right. In simple words, if I say the area around the magnet, suppose magnetic field, the area or the region around the magnet where its effect can be felt. Right, we can write in this way, for this cases we use field, or in simple words, we may write like this. The region around the magnet where its effect can be felt is known as magnetic field. Is it clear, all of you? Right? So, the region around magnet where we can feel or the magnetic effect can be felt on another object which is magnetic in nature is known as magnetic field. Right? चलो अब इन दोनों को हिंदी में समझ लेते हैं. फील्ड हम बेसिकली तब यूज करेंगे जब किसी ऑब्जेक्ट पे फोर्स लग रहा हो बट वो ऑब्जेक्ट एक दूसरे से टच में नहीं है. राइट. अभी देखो मैं इस मार्कर को इसे फेंकूंगा तो मतलब मैं इस पे फोर्स लगा रहा हूं. राइट. बट ये मेरे साथ फिजिकली टच में है, फिजिकल कांटेक्ट में, तो इसे मैं फील नहीं कर सकूंगा. राइट. अगर इस ऑब्जेक्ट पे मैंने फोर्स लगा दिया इसे बिना टच किए, राइट, इस ऑब्जेक्ट के ऊपर मैंने फोर्स लगा दिया बिना टच किए, तब मैं फील्ड वर्ड यूज कर पाऊंगा. समझ में? फील्ड वर्ड हम कभी यूज करेंगे. राइट. क्लियर? चलो अभी इस बात को समझते हैं. सी, मैग्नेटिक फील्ड यानी कि एक ऐसा एरिया है, एक ऐसा रीजन है जो मैग्नेट के चारों तरफ होगा. मैग्नेट के चारों तरफ जहां तक मैग्नेट का असर दिखाई देगा, राइट। मैग्नेट के चारों तरफ जहां तक मैग्नेट का असर दिखाई देगा, उस एरिया को, उस जगह को हम कहेंगे मैग्नेटिक फील्ड। राइट। अगर हम इसे अपने लोकल लैंग्वेज में बात करेंगे तो ऐसे हम बोलते ना, अपना इलाका। इलाका मतलब इलाका क्या होता है, कभी फिल्मों में आप लोगों ने सुना होगा, राइट, कि कोई पहलवान बोलता है कि कोई गुंडा मवाली, कोई भी उस एरिया का डॉन बोलता है कि पूरा मेरा इलाका है। मतलब उस एरिया में, उस इलाके में उसका असर होता है। वो भले वहां पे ना हो, बट उसका असर जरूर होगा। वो भले आपसे डायरेक्टली आपके सामने ना हो, फिजिकली कांटेक्ट में ना हो, आपको मारा ना हो, बट फिर भी वो कहीं और बैठ के किसी को फोन करेगा तो कोई और आके आपको मार पाएगा, क्योंकि उसका असर वहां तक होता है। ये बेसिकली फिल्मों में देखा जाता है, पुराने जमाने में हुआ करता था, राइट। सो इलाका मतलब फील्ड। अभी इलाके का मतलब पता चल गया ना, एक ऐसा जगह जहां पे हमारा असर चलेगा, राइट। हम यहां बैठे बैठे किसी को भी हम डरा सकते हैं, इन द फिल्म, अगर फिल्मी वे में बोलूंगा तो, राइट। मतलब हम किसी पे भी अपना असर छोड़ सकते हैं दूर बैठे बैठे। वही तो होता है ना डॉन का इलाका, राइट। वैसे ये मैग्नेट का भी अपना इलाका होता है कि उसके चारों तरफ वो अपना असर जरूर छोड़ेगा। जहां तक उसका असर दिखाई देगा या महसूस होगा, उस जगह को हम मैग्नेटिक फील्ड कहेंगे। इज इट क्लियर ऑल ऑफ यू? राइट। सो होप you have understood about the magnetic field very clearly now, right? Okay, so now we'll move on to the next topic as per your book within this next point. So magnetic field, hope you understood here. Now here what you have to do, see in this, to understand magnetic field, first of all, on a white paper, keep one bar magnet, north, south, right. Now, after keeping this bar magnet here on the white paper, you need to take a magnetic compass, right, and keep the magnetic compass here. And it will have the needle. The needle is pointing out like this. So starting point of the compass and ending point you mark like this. Okay? Again, remove needle from here. This magnetic compass you have to remove from here. Now at this point, you keep the magnetic compass. Now it will point out like this. So again, you keep one dot here. Again remove magnetic compass from here. Right. Now keep magnetic compass at this point. So wherever it is pointing out, there you keep one dot. Okay? Like this you keep on doing. Let us do this little bit with lot of patience initially. We'll do this practically also, student, in the coming videos. So again here you keep needle, it will point out like this. Wherever it is pointing out, you mark you keep a dot. Again keep needle here, means compass, it will point out like this. So you mark here, right, remove these compasses. Getting idea? So if you keep on doing like this, you'll be getting something in this manner. I'll be showing not directly. Do like this, keep on doing. So you'll be getting some dots like this. Right. Okay. So finally we'll be coming like this. Getting with this point, everyone? Now once you get this all the dots, what you have to do, you simply need to join them Join all the dots. Right. And mark the arrow from north, this direction. Okay everyone, like this you should do. Now next what you do, keep magnetic compass here and keep on following the same way as we did just now. You'll get one more like this. One more you can get like this, and here also you'll get like this. Okay. Getting idea everyone? So we'll get something like this when you keep on doing this experiment. So जब हम ऐसे एक्टिविटी को करते जाएंगे तो हमारे पास ऐसे लाइन्स आएंगे, राइट? These lines are nothing but imaginary lines. These are actually imaginary lines. They are not visible but they are present. And these lines are called as magnetic lines. Clear with this? And you keep on doing in such a way that at some point what happens, suppose you keep magnetic compass here, suppose above the board, the needle won't move. Here needle is moving, right? Needle direction is changing because the needle is within the field of the magnet. Now this complete area is the magnet's field. You keep needle anywhere, here, 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 here. Anywhere you keep the needle, magnetic compass, it will move, right? It will come to rest at one particular position, in a particular orientation. But if you keep magnetic compass here, here, it won't show any movement, any changes in the direction. Right, needle won't move when you keep the magnetic compass there, because this is not the field. Here you cannot see any effect of magnet. Here here you cannot see any force of the magnet on this needle. But here you can see some force is exerting on this. Needle will move automatically. See, that means magnet is here, compass is here. There is no physical touch, but still needle is moving. That means this is exerting some force on this, right? Needle was like this. Here needle will be like this. Here needle will be like this. That means without being in touch, it is exerting some force. That is what I said to you. That's we call it as field. The field is the region where magnetic effect can be felt. And here force will be applied. In field what happened? Force will be applied on the object without any physical contact. Clear with this point everyone? So hope you understood this all. Just continue it for a while. Okay? Right? Now, I said you, when there is one force which is making the needle to deflect, what are that force is said to be? That force is nothing but magnetic force, because who is applying that force? Magnet. So that force is called as magnetic force. Okay everyone? Right? And at every point, magnetic field will have its direction. Right? Now suppose, okay, magnetic force, hope you got the idea? Right? Magnetic force you understood? Right? This force, what I exerted on this, is known as magnetic force. Now, this magnetic field will have direction also. See student, suppose if I want to find magnetic field at this point, so I should keep the compass here. Then compass will be aligning along the tangent. So compass direction will be along the tangent. Right. Clear? Tangent means suppose if I want to find the, if I keep needle here, so this is tangent. The line touching the field at one point is known as tangent. So, suppose if I want to find tangent at this point, that will be like this. If I want to find tangent at this point, it will be like this. If I want to find tangent at this point, it will be like this. In tangents and secant chapter, we'll see in details. Okay? So, that means, what will be the direction of the field? Direction of the field at any point on the field line is in the direction of tangent. So, field का direction क्या रहेगा? किसी भी पॉइंट पे अगर हम फील्ड का डायरेक्शन फाइंड आउट करने की कोशिश करेंगे तो उस पॉइंट पे फील्ड का डायरेक्शन किस डायरेक्शन में होगा? टेंजेंट के डायरेक्शन में होगा. गेटिंग विद दिस पॉइंट? सो डायरेक्शन ऑफ फील्ड एट एनी पॉइंट ऑन दिस कर्वेचर विल बी इन द डायरेक्शन ऑफ टेंजेंट. मतलब फील्ड का डायरेक्शन क्या होगा? जो टेंजेंट का डायरेक्शन है वही फील्ड का डायरेक्शन होगा. राइट? अभी मैं यहाँ पे फील्ड का डायरेक्शन ढूंढना चाहूंगा तो टेंजेंट ड्रॉ करो, ऐसे आएगा, ये टच होगा. सो टेंजेंट ऐसे है ना, फील्ड भी ऐसे रहेगा. अगर मुझे यहाँ पे फील्ड का डायरेक्शन पता करना है तो यहाँ टेंजेंट ड्रॉ करो, ऐसे टेंजेंट जाएगा टच करते हुए, यही फील्ड का डायरेक्शन है. अगर मुझे यहाँ पे फील्ड का डायरेक्शन पता करना है, टेंजेंट ड्रॉ करो, यही फील्ड का डायरेक्शन है. राइट? सो द डायरेक्शन ऑफ द फील्ड इज नथिंग बट इट्स अ डायरेक्शन. It's in the direction of tangent. Clear with this? That means direction of field is one important characteristics. Direction of field is one of the important characteristics. Now what is another characteristic? Two characteristics will be there for any magnetic field. Right, for any field actually. We are discussing about magnet, but for any field there will be basically two characteristics. One will be the direction of field, which you understood just now. Another one will be the strength of the field. Right? Now, strength of the field depends on the magnetic field lines. See, in this area, so many magnetic field lines are there, very crowded. Right? When magnetic field lines are very crowded, that means in this area magnetic field strength is very high. Strength is very high. Here you see magnetic field lines are not that much crowded, so strength is low. Magnetic strength is low. मतलब जहां कहीं भी मैग्नेटिक फील्ड लाइंस क्राउडेड होकर रहेंगे, बहुत सारे फील्ड लाइंस रहेंगे एक जगह पे, तो उस जगह पे फील्ड स्ट्रेंथ क्या होगा? बहुत ज्यादा होगा. राइट? और जहां कहीं भी गैप ज्यादा रहेगा, फील्ड लाइंस कम रहेंगे, राइट, उस एरिया में मैग्नेटिक फील्ड स्ट्रेंथ कम रहेगा. अंडरस्टूड एवरीवन? राइट? सो मैग्नेटिक फील्ड के दो कैरेक्टरिस्टिक्स है. क्या है वो? एक डायरेक्शन ऑफ फील्ड, एक और क्या है? स्ट्रेंथ ऑफ फील्ड. गेटिंग विद दिस पॉइंट ऑल ऑफ यू? राइट? चलो देखो भी जल्दी से ऑब्जर्व करो. ओके, क्लियर? चलो अभी एक और टॉपिक, लास्ट पॉइंट इसमें का. सी हियर these magnetic field lines are 3D in nature. Magnetic field lines are 3D in nature. That means magnetic field will be in every direction around the magnet. 360 degree magnetic field will be available. Suppose this is magnet, right? Clear? Suppose this is magnet, the magnetic field will be everywhere. This here, up, down, left, right, anywhere. Here. So magnetic field will be present everywhere around the magnet in 360 degree. That means 3D. Right. Now what you do, you keep magnetic compass above the magnet, then also it will deflect. If you keep below the magnet, then also it will deflect. If you keep in this direction, then also it will deflect. If you keep here, then also it will deflect. So, what does it say? It says that magnetic field is present everywhere around the magnet. Is it clear everyone? Right? So, पता चला मैग्नेटिक फील्ड क्या है? 3D है. ये हर जगह रहेगा. इसके चारों तरफ रहेगा मैग्नेट के. ऊपर नीचे दाएं बाएं आगे पीछे इधर उधर कहीं भी इस मैग्नेट के सराउंडिंग में हर जगह मैग्नेटिक फील्ड अवेलेबल रहेगा. राइट. आप चाहे तो मैग्नेट के ऊपर कंपास लगा के देखो, कंपास का निडल हिलेगा, डिफ्लेक्ट होगा, क्योंकि वहां पे फील्ड अवेलेबल है. नीचे लगा के देखो तो भी डिफ्लेक्शन होगा. दाएं लगाओ डिफ्लेक्शन होगा, बाएं लगाओ डिफ्लेक्शन होगा, कहीं भी लगा दो किसी भी एंगल पे डिफ्लेक्शन होगा. इसका मतलब मैग्नेटिक फील्ड क्या है? हर जगह मौजूद है. इसलिए से हम 3D कहेंगे. ओके स्टूडेंट्स, सो ऑलमोस्ट ये वीडियो हम यहीं पर रोक देंगे. लेट वी स्टॉप दिस वीडियो हियर विद एक्टिविटी 2. In third video we'll discuss activity 3 student. It's been quite lengthy. In order to just make it like in terms of time, we are trying to make short videos. Okay, right? So clear with this? So in the next video we'll see the next part, that is activity number 3. Till then, it's a Jai Hind to everyone.